Good evening everyone. Welcome to week 5 of Data Science for Engineers course. I am Elsa Sharu Johnson from NIT Tiruchirappalli. So those who have done the last day's discussion class, you might have gone through the theory of week 5 Data Science for Engineers course. So I'll be giving you a brief review of the theory and then we'll move on to the problems, okay? And so let's start the class. So if you have any doubt, you can put in the chat window, or you can unmute your mic and ask your queries. So and during the problems also you can put the answers in the chat window, okay? So anyway, people still are waiting for joining. So constraints optimization we saw in the last class, not in the present session. So like unconstrained optimization, the function we examined were unconstrained, meaning that they either had no boundaries or the boundaries were soft, okay? So you can see this figure there. In that figure, what is written is that there is a curve with no boundaries. All right, there is a curve given there and it has no boundaries. So that means that the boundaries were soft, and we had solved some problems where there were no constraints which were defined, okay? And we had seen optimization to do unconstrained optimization for univariate as well as multivariate problems. Now in this week we will be seeing constrained optimization, or we'll be examining functions with a constraint, okay? This constraint is a hard limit which is placed on the value of a variable, which prevents us from going forever in certain directions, okay? So in simple terms, this example you might have seen earlier also, okay? Just I'll be mentioning that because if you have a car which travels from Surat to Mumbai, okay, and we have given a constraint for that, the constraint is like it should visit through Nashik city, okay? So if it was an unconstrained problem, you can look at the map here. If it was unconstrained, then it takes about 5 hours 42 minutes. It's written there. So this is taken sometime earlier. This figure is taken sometime earlier. So you can see here that if no constraints are there, this is the route that should be followed to reach this particular destination, okay? And if we are giving a constraint that it should visit Nashik city, then this is the route which is given, and you can see that while we give that constraint, the time for traveling has increased, okay? So this particular example you can compare it with the example which was given in your course itself, okay? So this is known for you. So another small example I have given, you are given with a problem like climb as high as possible on the mountain to have a better view of the moon, okay? So it's a hill, there is a path, so the constraint will be like your car should be on the road, okay? So it's like if you start from this particular point, you can travel directly and reach the top. That is one of the option. But still, if you are given with a constraint that the car must be on the road, then you have to follow a certain particular path. And look, you can see here the path is like little winding road, right? So it takes more time, okay? But still, that constraint is important, okay? Now we'll move on to the next one, equality constraint optimization. So in equality constraint optimization, you'll be given an optimization objective, okay? And it will be like minimize for x1 x2. The objective function will be 2x1 square plus 4x2 square, and such that the constraint will be given like 3x1 plus 2x2 equal to 12. So this 3x1 plus 2x2 equal to 12 is a line, okay, and this is the contour where the objective function is given. So if you look at this figure, okay, in this figure, if it was an unconstrained problem, this was the minimum, okay, this was the location of the minimum. But when you give a constraint as defined by this line, the point or the minimum point should lie on that line, okay. So this is what is known as constraint minimum. So the yellow star represents constraint minimum. This also was given in your lecture classes, lecture videos. So just for an example with that, I'll have a rectangle whose perimeter is 20 meter. Find the dimensions that will maximize the area, okay. So our problem is like, so we'll first consider the breadth as B, length as L, and area as A, and perimeter P. So our maximization problem is fx equal to A, f of x equal to A. Area has to be maximized. The constraint is given by the perimeter, okay. So perimeter is given by 2L plus 2B equal to 20, okay. So what we have to do for this one, we'll apply the first order condition for constraint minimum, okay. So how can you write that? It's like usually this one, grad of f equal to minus lambda into, you can say this, into g, okay, grad of g. So f, you know that it is LB right now, and g of x is 2L plus 2B, okay. So that also I'll write f of x is, or you can say that it's not x right now, f of LB, okay, is equal to L into B, and g of LB, you can say that it is equal to 2L plus 2B minus 20, okay. Now if you solve these things according to this formula, then you will be getting it like so if you solve, so this just you might have seen writing a Lagrangian, right? So Lagrangian of L comma B comma lambda, if you write, then you can say this as, okay, LB, and this, if you have given it like this, so it like plus L lambda will come, so LB plus lambda into 2L plus 2B minus 20, okay. So if you solve for this, like find the L dash, okay, the first derivative condition, so you don't have to go this much actually. Anyway, I have written it, I have solved for that, okay. So here if you write this one, just to have to take the derivative of these things, okay. So derivative will be giving like the first, with respect to L, it will be given like L plus 2 lambda equal to 0 is one equation. Then the other equation will be okay, just wait for a moment. So dou L by dou this small l will be giving like B plus 2 lambda, and dou L by d small b will be giving like L plus 2 lambda again, okay. So from this you will be getting L equal to B equal to minus 2 lambda. This is given in these equations, okay. And then your third equation, the constraint equation, is this one. Then solving the equation 1 as well as 2, you will be getting L equal to B. That is can be observed, right? Then these values we will put in equation 3. So equation 3 will be given like minus 2 lambda into 2 will give minus 4 lambda plus, sorry, Yeah, in this equation you will be getting. So here you can substitute, and the substitution will be giving in the form. So yeah, just wait a moment. So okay, yeah, I have come back. Yeah, so okay, here you can write like just substituting in the equation 3. Okay, so here L equal to minus 4 lambda will come. Just I will write here. Okay, sorry. Okay, yeah, in equation 3 will be giving you like 2 into minus 2 lambda, it will be minus 4 lambda. Okay, minus 4 lambda, again minus 4 lambda will come, equal to 20 will come. Okay, so lambda will be equal to in this case, so a problem will be coming, right? Just wait a moment. Okay, so I've just given this L equal to B there, not that one. Yeah, lambda value will be minus 2.5, that is true. Okay, but that is not required anyway, that is fine. This is fine. Okay, that I can write, but what I want to do is, you don't want to go through this anyway. Okay, just I have got L plus B equal L equal to B. Yeah, you can do like that, but directly, since I have got L equal to B, you can write 2L plus 2B, 2L you can write equal to 20, and directly you can get the length value, and you have got breadth equal to L, then that also can be given like 5. Okay, if lambda value is asked, you can put this one. Okay, so anyway everyone is familiar with that. We'll move on to the next one. Okay, find the points on the circle 2x x square plus y square minus 80 which are closest and farthest from the point 1, 2. I think you might be having similar questions in other sessions also. Okay, so these similar questions come in other sessions also, so one of these models we can do first, and then we can, the others can be done. Okay, so the thing is like, first is we have given a condition. We are given with a circle which shows like this circle is given x square plus, I hope you can see this in this space, right? Yeah, x square plus y square minus 80. Okay, then we are asked to find out which are the closest to and farthest from the point 1, 2. Okay, so I have just depicted this figure after finding the answer. Okay, anyway, we'll solve this one. So it's like to find distance from any point xy to point another point. So this point is given, right? So the equation is like d equal to root of x minus 1 the whole square plus y minus 2 the whole square. Okay, this is the distance which is given. So just you can remove that root, because if you are maximizing this particular, so our objective is like maximize this function. Okay, so that means that you can remove the root and maximize also, that's not a problem. So maximize f of xy I am writing as x minus 1 the whole square plus y minus 2 the whole square. So then this is our constraint given, x square plus y square equal to 80. So the same condition we are applying here, and so then we'll be getting this as x minus 1 the whole square plus y minus 2 the whole square plus lambda into, so it's since it's given del equal to minus lambda del g, so, okay, so you can give like plus lambda into x square plus y square minus 80 I'll be giving, okay, equal to 0. Then you have to solve like get dou f by dou y, dou f by dou x, okay, this way also you can solve, and this in this way also you can solve, okay. This here it's like dou f by dou x is taken for both sides, okay. So and just consider this as dou, okay. So if you find this one, if you'll be getting it like okay, we'll solve from this one actually now, right now. So if you see that, you'll be getting 2 into x minus 1 plus 2 lambda x equal to 0. That will be one of the equation, right? Here also is written like that. And the other equation will be 2 into y minus 2 plus 2 lambda y equal to 0. That's the other question. So while solving this one, all right, the final answer will come like this one, okay. So it will be coming like so it will be coming like you can get the value of lambda from here, okay, x and y from here. 2 into x minus 1 equal to 2 lambda x, right, and then 2 into y minus 2 equal to minus 2 lambda, okay. Just solve for this one. So here you can see how it is written, x minus 1 by x. So you have you'll reach here, right? Here it will be like x minus 1 by x equal to minus lambda, and if you solve the other one, you'll be getting it like y minus 2 by y equal to minus lambda, okay. So the same thing is written here, x minus 1 by x equal to minus lambda, y minus 2 by y equal to minus lambda, and here we have the constraint. So then what we'll be doing is like solving the equation 1 and 2 will give y equal to 2x, okay. Just solve for this and find the answer, because you can equate these two and then you can put in this value, okay. So the substitution will give you like, so anyway from these two you have got x minus 1 by x equal to y minus 2 by y. From that you got y equal to 2x, then x square plus 2x square equal to 80. At the end you will be getting 5x square equal to 80, which will give you x equal to plus or minus 4, okay. Then putting these x values in 3 will give y also like plus or minus 8. So you will be getting two sets of values. It's given like 4, 8 and minus 4, minus 8. We are asked to find the point which is farthest and closest to the point 1, 2, okay. Just so we'll be doing a rough graph, and although another method is like you can find the distance between the points, but anyway that's not required, because these are, I mean, we only have an xy coordinates, xy plane only we are having, okay. So Cartesian coordinates only, so we can just draw that and see which one is the farthest and which one is the closest, okay. So here you can see 4, 8 is the nearest, right, and minus 4, minus 8 will be the farthest, okay. Then the next question is f of x, y, z equal to x plus z. and g of xy is equal to x square plus y square plus z square minus 1. So applying the first order condition, just wait a moment. Okay, applying the first order condition, this same condition, right? So how you can solve this, you might be already knowing it anyway. Just I'll write that here. So here it will be, you can write in this form, x plus z, okay, plus x square plus y square plus z square minus 1 equal to the function. Okay, so then solving that, we'll be getting minus 2 lambda x equal to 1, minus 2 lambda y equal to 0, and minus 2 lambda z equal to 1. Okay, solving 1 and 3, we will get x equal to z, and with equation 2 we will get y equal to 0. That is fine, right? This is fine, right? You can see that. So substituting in the constrained equation all these things, we will be getting x equal to plus or minus root 1 by 2, and you know that z is equal to x itself. So we'll be getting the point 1 as this one and point 2 as this one. Okay, so it's a straightforward question only. Now inequality constraint optimization. So this one is like minimize 2x1 square plus 4x2 such that 3x1 plus 2x2 greater than or equal to 12. Okay, so in this one it's like just we had a line like this, 3x1 plus 2x2 equal to 12, and it's written like greater than this particular value. So in that class this same example was taken, right? So here it in this particular case the unconstrained minimum is denoted by this red point, and this yellow star represents the constrained minimum, but here it's asked like greater than or equal to 2. So in this region, in anyway it will be lying on this line only because greater than or equal to is given. Okay, so this is an example of an inequality constraint optimization. Then multivariate inequality constraint, if you are given such a kind of a problem, so it's like minimize this particular problem. Okay, this is the same problem and some error is there. Okay, so 3x1 plus 2x2 less than or equal to 12 will be below this particular line. Then 2x1 plus 5x2 less than or equal to 10 will be in this particular region, and x1 less than or equal to 1. So all comparing all these three, the feasible region will be this one. Okay, so this one, okay, this is the equation actually. So here you can see that the same constraint I have written. Okay, here there is one correction here, like, okay, you can, this I'll be writing it later. Okay, and this is greater than, so yeah, so here this question. Okay, so here this is the Lagrangian which can be written. Okay, and the first order KKT conditions is written. So how do you find that? You have to just do a differentiation with respect to this Lagrangian with respect to x1 as well as x2. So you'll be getting these two equations also, and then we'll be writing the constraints like mu into this one and mu2 is equal to like this. And the thing that you have to note here will be like, if less than or equal to 12 is there, you don't have to make any changes. You can directly write 3x1 plus 2x2 minus 12. If it's a greater than simple inequality given, then what you have to do is you have to make it in the form of a less than equality constraint. So it will be coming like 10 minus 2x1 minus 5x2. So that's why this form came. And then the third one is given like x1 less than 1. So so this one is like x3. Okay, so x3 less than or equal to 1, so x3 minus 1 equal to 0, and all the constraints should be greater than or equal to 0. So these are the all the mu values. Okay, so these are the things that you have to take care. Okay, so regarding this, certain one set of table was given. This table is given in your lecture slide or lecture course also. So it was shown like many different conditions were given where the active or inactive constraints were given, and the solution, if it's a possible optimal solution, and the remarks about that. So while going through the lecture, you might have found out that this particular thing, the fourth entry, is where all constraints and KKT conditions were satisfied, right? So this was done by finding out different ways, right? This I think you might have listened to that. So first you will be putting like either any of these conditions, any of these constraints equal to 0, so that indicates that mu1. So for example, if 3x1 plus 2x2 minus 12 equal to 0, that means mu1 will be active. Okay, so likewise many different variations had been done. So for all those variations we are seeing the value of x as well as mu. So you can see that in this particular fourth entry, two of the constraints were active. So active constraints means the constraints are active, meaning like mu2 mu3 will have values, and the other 10 minus 2x1 minus 5x2 and x3 minus 1 will be 0. Okay, so solving that, we got values for mu, and we got it as mu 2.56 and 1.12, and the other equations also have been used for solving this one, right? I mean, if these are the equation, anyway 5 equations will be there. So here it will be like if mu2 mu3, in the fourth case, if mu2 mu3 are active, then it will be like 10 minus 2x1 minus 5x2 equal to 0 will be one equation, x3 minus 1 will be another equation, then 8x2 plus 2 mu1, this one will be another equation, and this one another one. Okay, and this bigger one. Okay, so all solving for all these things, you will be getting it like this value. Okay, in the other cases, in some of the cases there came negative values. So in this particular case, this is okay, this is fine, but yeah, in here, in some of the cases, one of the constraint might not be satisfied. Okay, in this particular case, when these two constraints were inactive, this mu2 and mu3 were 0, and this value came like this one. But the one thing which had not happened is like x1, this one should have been less than or equal to 1, but here it was not equal to less than or equal to 1, so that led to rejecting this particular solution. Okay, so the optimal solution which have been obtained is this particular solution. Okay, so solving this you can try later. Okay, and examples have also been told in the videos also, right? So that is the thing. And okay, this is x1 minus 1. Okay, yeah, so all the graphs for all these things have been represented as a plot also. Okay, in the first thing is like all constraints are active, and we have drawn the lines according to that, but if all are active, then all should be meeting at a point, which does not happen for this particular case, so it's rejected. So you can see many other constraints which are coming. In the only case, in this case only, they both are meeting at a point, right? In this particular case only, so that's why it's an optimal solution. Okay, now we'll move on to the assignment questions of week 5. First I'll be starting with the assignment questions of July 2023, and then the rest of the courses we'll be covering. Okay, rest of the previous run courses we'll be covering. So the first one, this particular question has been repeated in another sessions also. So it's like the objective function is like maximize f of x is equal to xy subject to the condition. So you can also solve this and tell me the answers. So the first is written like a b c. Okay, so just wait a moment, I haven't kept my okay, yeah. So this is the function. This function is to maximize f of x, right? And subject to the constraints x plus y square less than or equal to 2 and x comma y greater than 0. The Lagrangian function is also given like this, xy minus mu1, and since you can see that it is like given like minus mu1. Okay, so it's written in this way, minus x minus y square, it is taken to the other side. Okay, so but okay, so this is the Lagrangian given, and minus mu2x minus mu3y, because the other constraints are xy greater than or equal to 0. So why have it been written like that? Because we usually have looked at this thing as minimize, right? Okay, so minimize, in the minimization problem we'll be looking at making everything less than or equal to. Here you can see that the question is a maximization problem. Okay, maximize f of x equal to xy subject to these conditions. So that's why we are taking it like maximization mean, so we are bringing it to 2 minus x minus y square greater than or equal to 0. Like that form we are converting, and the other things are x greater than or equal to 0 and y greater than or equal to 0, since it was a maximization problem. If it was a minimization problem, then the opposite would have happened, like it would have been written as x plus y square minus 2 less than or equal to 0. Okay, so this is not read right now. So okay, so which of the following is not an apt representation of the constraint is being asked? Okay, I think you can solve this. Okay, so first one is written as x plus y square less than or equal to 2. Okay, the next one is minus x greater than or equal to 0, and the next one is minus x less than or equal to 0. So anyway, this constraint is already present in this way, it's okay. Then the next one, you can see that you have written it like x greater than or equal to 0. Then the topic is minus x, so minus x will be less than or equal to 0, right? So this one is right. Okay, so the solution is B. Haven't seen any answers here, so you can solve that and put the answer. Okay, so right now in the first question the answer is B. The given constraint has not been mentioned as a part of the problem, or it is like in this particular problem the opposite have been mentioned. Okay, so next one, the same question, maximization function. So it's a connected question, and in this one the values of y1, y2 and y3 while evaluating the KKT condition with all the constraint being inactive are. So it's written like all constraints are inactive, all constraints are inactive. Okay, so just inactive means we are not looking at that constraints. Okay, so in that particular case you can put the answer in the chat window. This is no calculation required, we have already seen this one. In this case, yeah, one has put B. So if all are inactive, you can see from here also, right? Yeah, so okay, the answer is mu1 equal to mu2 equal to mu3 equal to 0. Okay, so when all constraints are inactive, these are 0. Now the next thing, consider the function 5x square plus 3y square plus 8xy plus 12x plus 6y as the function to be optimized and answer this question. So here it's asked like the saddle point. Okay, so the saddle point for this particular function you have to find out. So you can just see that and solve for that. So first what we have to do is find out this one. Okay, so it will be coming like 10x plus 8y plus 12, and you can put equal to 0, and the other one will be coming like 6y plus 8x plus 6 equal to 0. So solving this, you can solve for this and tell the answer. I'll be putting this as A, B and C and D. Okay, so 8x plus 10x plus 8y equal to minus 12, and 8x plus 6y equal to minus 6. You can solve for the answer. So I am seeing the answer as D. Okay, so any other answer? So this values that you'll be getting is x equal to 6 and y equal to minus 9. So just I think last class also you have seen how to find out. Okay, so here I mean different constraints are not there, this we had seen earlier also. So if you see you have to solve for the matrix, and anyway, so that answer A is like, yeah, 1%. Okay, so what you have to do is you have to take the second derivative also. Okay, and see which is that point. Okay, so when we solve like x equal to 0, y equal to 0, you got xy equal to 6 comma minus 9. But that if you see the Hessian and then solve for that, then you can find that it is like not a saddle point. Okay, so you can give this answer. Okay, then so next one is like a circle with center at origin is defined as x square plus y square equal to 250. Find the points on the circle at the minimum distance from point 10, 1. So this one, a circle with center at origin is defined as x square plus y square equal to 250. Find the points on the circle at minimum distance from the point 10, 1. So this kind of question we have already seen. You can also start solving this one. So it is defined like a circle. Okay, so circle defined by x square plus y square equal to 250, and we are defined. So the same question that we have seen in the example, same kind of question. So it's like minimize f of xy. The point which we have been given with is 10, 1. All right, so if minimize f of xy equal to, I'll find the distance between any two points. So it will be like the point, I'll be taking it as x, y. Okay, so distance between these 2 points we have to find out where this point is in the circle. Okay, sorry, this point, the xy point is on the circle. So for that, anyway, I am ignoring the root as I have told earlier, and I am putting x minus 10 the whole square plus y minus 1 the whole square, because it's 10 comma 1. Okay, so then our g of xy is equal to x square plus y square minus 250. Okay, minimum point is asked. So then there are two methods of solving this one. So I have got answer from Gautami, yeah, as 15.7 and 1.573. okay, so one of the methods, as I have told earlier, is to put this like in this form, x minus 10 the whole square plus y minus 1 the whole square plus some lambda or mu into x square plus y square minus 250 equal to 0. Then you have to solve these for these equations. Okay, and if you solve, you will get the value as just wait a moment, I'll directly write the value. So there you'll be getting in the form of equations like, if you solve this, it will be getting like 2x minus 10 plus 2 lambda x. Then another equation will be 2 into y minus 1 plus lambda into 2y, and x square plus y square minus 250 equal to 0. Then solving this, x equal to 20 by 2 plus 2 lambda, y equal to 2 by 2 plus lambda 2 lambda, and putting these in this equation, okay, you will be getting the value of lambda as minus 0. You will be getting the value as minus 0.364 and minus 1.635. okay, so this one you can substitute for x and y, and the values that you will obtain is given by x equal to 15.72 and 1.572. just wait for a moment, people are joining. Okay, 15.72 and 1.572, and the other one will be minus, other option will be minus 15.72 and minus 1.574. okay, so in the options, the one which is given there is A, as Sridhar have pointed out. Then this is one of the ways of solving. Now you can also solve this in another way. okay, so it's like the condition for finding stationary points in the case of a multivariate problem can also be given in this way, which is the same. okay, so it's like you can calculate dou f of xy by dou x into dou g of xy by dou y. Directly you can write in this form, okay, minus dou f by dou y into dou g by dou x equal to 0. In this form, it's derived from the other form only. So in this way, if you write, you can directly get, without calculating the lambda value, you can directly get this one, 2 into x minus 10 into 2y minus 2 into y minus 1 into 2x equal to 0. So this you'll be getting an equation like this. Then you can solve for this equation, right? Okay, you'll be getting here like x equal to 10, y anyway from this equation you'll be getting, and substituting for x in the constraint earlier, we will get y equal to this one and x equal to this value. So optimal values will be 15.73, 1.573 and minus 15.73 and minus 1.573. okay, then the coordinates that are closer to the point will be 10, 1, different than the minus values which are in the negative third quadrant. okay, it will be farther away, so you can get the answer as A. okay, so like this also you can solve, but it's like first you have to find the lambda value and then you have to find the x and y value. If it's like two variables only present, so here we have x and y only, so we can directly do in this method and get the answer also. Okay, now the next question, a function is defined as f of xy equal to 10x plus 5y plus 29. Find the maximum such that the constraint 5x plus 5y square is equal to 44 is satisfied using a Lagrange multiplier. Okay, so for this one, our function is this, okay, and constraint is this, okay, and we are asked to find the maximum. So for this one, okay, we'll be first writing the Lagrangian. Okay, so the Lagrangian can be written as 10x plus 5y plus 29, okay, minus lambda into, in this way you can write 5x plus 5y square minus 44 equal to 0. In this way you can write, depending on the value of lambda this equation will change, so that's not a problem. So first, so this is the Lagrangian given by L of x comma y comma lambda here. Then what we'll do is we'll find the L dash, the derivative of the Lagrangian, okay, that anyway you know, right, it's dou L by dou x, dou L by dou y, and dou L by dou lambda. Okay, so this is the thing. So if you equate this to 0, you'll be getting the answer. Anyway, so we'll be finding out what are these values. So first you'll be getting 10 minus 5 lambda, next one will be 5 minus 10 y lambda, and next one will be 5x, so minus will be there, minus of 5x plus 5y square minus 44. So you can also put the answer. So if you solve for the first one, you will be getting a lambda value, right? So lambda value will be coming like 2. Okay, then in the second equation you will be getting 5 equal to 10y lambda. Okay, so y value you will be getting like 1 by 4, that is 0.25. Okay, then here again you can substitute this one, this equation, y and lambda values, you can, y value you can substitute here. So here it will be like 5x equal to 44 minus 5 y square, so it will be like 44 minus 5 into 0.25. okay, so this value will be coming around 8.7375. okay, this will be the value, so it's closer to 8.738. yeah, I have got the answer from one person also. So answer is A, 8.738, and y equal to 0.25. Now the description is also given. Now the next question is, a manufacturer incurs a fixed monthly cost of 7350 and a variable cost C of m equal to 0.001 m cube minus 2 m square plus 324 m dollars. The revenue generated by selling these units is R of m equal to minus 6 m square plus 1065 m. How many units produced every month will generate the maximum profit? Okay, so for this one, first you have to see what is a profit. Okay, so you are given like the total cost you have been given, okay, and revenue also given, right? So you have to find the profit. So profit is usually, it's like revenue minus the cost of the production. So for this particular purpose we have to write it like 6m square plus 1065 m minus 0.001 m cube plus 2m square minus 324 m. In this form you have to write that. Now you are asked to generate the maximum profit, right? So you have to maximize this particular profit. Okay, you have to maximize this one. So maximization, first what you have to do, you have to find the derivative dou p by dou m. Okay, so here you will be getting it in the form of, okay, so first you can simplify this function. It will be minus 0.001 m cube minus 4 m square okay, just wait a moment. And this is like, I have missed one thing also, there is like, okay, so C of m I'll write here. C of m is like, the cost is like this particular thing, 2m square plus 324m plus this is the variable and 7350 is the constant cost. Okay, so that also should be included here, and so here it will be coming like 7350, right? So this here it will be coming in this form, 1065m minus 324m will give you 741m and then minus 7350. Okay, so just take a derivative of this one. The derivative will be coming around minus, okay, it's 3, so 0.003 m square minus 8m plus 741. Okay, that will be the answer. Then what you have to do is you have to equate it to 0, and this you can do in a calculator and tell the answer. So anyway, m will be coming around, m square will be coming around, when you solve for m, just put this in the calculator, and m value will be coming in this way, 89.61. okay, you can check this answer if you are getting. Then m, in the looking at the options, you can write like 90. Okay, just you can see if everyone's getting the answer. Just you can put some response if you have got the answer. Okay, I have written this only actually, that one more another answer is also coming. Okay, another answer, when you solve this quadratic equation, you will be getting like one more answer will be coming, like minus 2756.28 also will be coming. Okay, but anyway, this can't be taken because it's like m is like how many units will be produced, so minus value you can't take. That's why I have taken 89.61 and the value has come as 90. So I think it's clear. So next one, an optimization problem solved for n variables with one equality constraint will have. You can put the answer in the chat window. Okay, I'm getting A. We have n variables and one equality constraint. Okay, the optimization problem has n variables and one equality constraint. Just can you so in our earlier problem here, it was like a function which had two variables here and there were three constraints, right? So totally at the end we had this much, right? Okay, so likewise so how many total equations will have come here? So from that, if you look, the answer will be actually n plus 1 variables. Okay, we have one equality constraint as well as n variables are there. Okay, so it is like the problem will contain n plus 1 variables, that means n decision variables and one multiplier variable lambda. Usually you will see that here now, because our function equation will be having some kind of decision variables like x, y, comma, z, and there will be another lambda also, okay, which can be found using n plus 1 equations, n equations solving this one and one equations by solving constraint this one equal to 0 where I equal to 1, 2, comma up to n. So the answer in this case will be B. Okay, for those who have written A, there will be n plus 1 equations plus n plus 1 variables. Okay, now questions for Jan 2023. For a function f of x equal to 2x square minus xy plus y square minus 3xy minus x minus y, the stationary point xy is asked. Okay, so just a hint also was given. Stationary point is a solution to the first order necessary conditions for maxima or minima of f of xy. So anyway, that also is given, so you can directly solve for this equation and find the answer. So you can start solving this one. So this will be like f of xy is given, right? So directly first order necessary condition you can take. So that will be coming like dou f by dou x. If you see, then it will be coming like 4x minus y minus 3, and dou f by dou y will be coming like minus x plus 2y minus 1. Then these two you can equate it to 0. Substitute, calculate in the, you can use the calculator to find out the answer for x and y. Okay, minus x plus 2y equal to 1. This you can solve in the calculator and tell the answer. Put the answer in the chat window. So I got an answer as D. Everyone has the same answer. Yeah, you'll be getting like 1, 1. Okay. So this answer will be taken as 1, 1. Everyone has written that answer. Okay, yeah. So the Hessian matrix for f of xy, the same question, the matrix is also asked. Okay, so for that you can do the double derivative, right? D square f by dou square f by dou x square, dou square f by dou x dou y, dou square f by dou y dou x, and dou square f by dou y square. So for that you will be getting the answer as in the first case it will be 4, in the second case it will be -1, and in this one same -1, and the last one like this. Okay, so you'll be getting the answer as, I think you might have got the second one also right. Hessian matrix is asked, so the first thing it will be -1 1, sorry, it will be 1 1. Okay, this will be the answer. And in the second one it will be 4 -1 -1 2. Now the eigenvalues of matrix f of xy equal to, okay, so this all the options look like having so many decimal points, like 6 decimal points, so its eigenvalue calculation is certainly little difficult, right? I mean, you know the steps for calculation. If you have the Hessian matrix, then you have to find, like, so if the matrix is given, then h minus lambda in lambda I you have to find, and you have to find the determinant. That is only required. Okay, so anyway we'll find the eigenvalue in another way. So what we'll be doing is we'll go to the R Studio, and here I have written this function 4 -1 -1 2 as a matrix, and I'm giving n row equal to 2 and by row equal to true, and I have loaded that particular function. So constant is like 4 -1 -1 2. Then I am getting eigen of constant, I'll be getting these values. Okay, so this is the value 4.414, this one 1.585. So we'll be coming back to the PPT, and here you can find, like, since these values are there, I'll just remove that one. Okay, so here when we have done with the R Studio, we have got values as 4.414 and 1.585. okay, so that one 1.585 and 4.414, this one, this is the answer. Just wait a moment, I'm not getting the eraser. Okay, wait for a moment. So here just ignore this one because I'm not able to erase that one right now. Okay, so this is not the answer anyway. Yeah, I've already keep the, yeah, that's why. Anyway, so yeah, just so this one won't be the answer, this is not the answer. Okay, the answer will be 4.414 and 1.58. okay, yeah. So next question will be the Hessian matrix of f of xy equal to 2x square minus xy plus y square minus 3x minus y is. So you have seen here that we have got the answer as 4 -1 -1 2, right? So they are asking, like, what will be the answer, the same question. So you can put the answer for this one. Last class also we have discussed like how to name it, like positive definite or negative definite or positive semi-definite. This answer will be, so our matrix is right now 4 minus 1 minus 1 2. Okay, so Gautami is giving like positive definite. Okay, so eigenvalues are positive, right? Yeah, so positive definite you can tell. So the since the eigenvalues were, just we have calculated the eigenvalues using this one, right? So we got the eigenvalues like 4.414 and 1.58, which are positive eigenvalues. So we can write the answer as positive definite. Yes, so use the following information to answer question 5, 6, 7, 8 like that. Okay, so which of the following is the stationary point for f of x1? This question I think you might have already seen. Anyway, I'll write them. It's a minimized question. F of x1 comma x2 equal to x1 square plus 4x2 square minus 2x1 plus 8x2. Okay, so just find the stationary point for f of x1, x2. Just go through your previous questions also. I think similar question itself has come up. Okay, so if you solve for this, actually first what you have to do is find out the first order condition. Okay, so if you do that, you'll be getting it like 2x1. Okay, I've got the answer B. Okay, we will see. Yeah, so anyone else? Okay, everyone is answering, so that is right. Okay, that is true. 1 minus 1, so yeah, so 2x1 minus 2 equal to 0 and 8x2 plus 8 equal to 0. So you'll be getting like x1 equal to 1 and x2 equal to minus 2. So second, B is the option. Next question, find the eigenvalues corresponding to Hessian matrix. So similar like earlier problem itself. So for this one, what you have to do is you go on to find the Hessian matrix. So Hessian matrix you can find like this one will be 4, and so in this particular condition, yeah, okay, this square won't be coming, I'm sorry. 2x1 minus yeah, 2x1, here it will be 2x1. Okay, have made a mistake earlier. So this one you'll be getting like 2. Okay, 20, your answer will be 2008. I hope you got this answer. Anyway, so this one, finding the eigenvalues are easy, right? Because if you write like h minus lambda I, determinant of h minus lambda I equal to 0, if you write, it will be in the form of 2 minus lambda 0 0 8 minus lambda, right? If you find the determinant, it will be coming like 2 minus lambda into 8 minus lambda equal to 0. You'll be getting the lambda value as 8 and 2, right? So that is also, answer is C. Okay, I haven't seen any answers here for eigenvalues. Okay, so eigenvalues are 2 and 8. I hope you all understand how to do that. So doing this solving for the Hessian matrix, you'll get the eigenvalues as 8 and 2. Next is find the minimum value for f. Okay, so eigenvalues you got, that means your matrix is positive definite, right? So then anyway, you will be looking at the values which correspond. So 1 minus 1 is the value of x1 and x2, and your matrix is x1 square plus 4x2 minus 2x1 plus 8x2. Just substitute the values, x1 equal to 1 and x2 equal to minus 1. When you substitute, you will be getting 1 plus 4 minus 2 plus minus 8. Answer will be coming like minus 5, which is B. So this also is solved. I got many answers also. That's fine anyway. Yeah. What is the minimum value subject to the constraint x1 plus 2x2 equal to 7? Earlier there was not a constraint given. Now a constraint is also given. So our initial value of x1 comma x2. So now we have to solve again. So f of x1 x2 is given like x1 square plus 4x2 square minus 2x1 plus 8x2 is our function. Okay, minimum value of the function, minimization is required, and we are given the constraint like x1 plus 2x2 equal to 7. Okay, so I got an answer like C and B. Is this for the previous question or okay? Anyway, we'll solve this one. So what you have to write is, you have to write x1, so it's like x1 square plus 4x2 square minus 2x1 plus 8x2. Okay, and minus or plus lambda you can give, minus lambda plus 2x1 plus x1 plus 2x2 minus 7 equals. Okay, so this is your function. So what you can do is, you can find the first order derivative of this one, and the first order derivative will give the answer like, if you solve this one, you will be getting it like x1 equal to, just I'll write the answer. If you have any doubts, I'll solve this later. x1 equal to 5, x2 equal to 1, and lambda you'll be getting like 8. Okay, so now the minimum value is asked, right? So the minimum value, one of you have answered C. Okay, two of you have answered C. So it's like, if you put these values, you'll be getting the value of f of x1 comma x2, that is f of x1 equal to 5 and x2 equal to 1. You will be getting the answer as 27. Okay, so anyone requires any explanation for that, I'll be giving the full steps. Otherwise we can go to the next question. Sridhar, do you have a question? So I think we'll move on to the next question. So the answer is 27. Find the maximum value of f of xy, 49 minus x square minus y square, subject to the constraint x plus 3y equal to 10. Okay, so this one can be given like, just from, so we have x of xy like this and constraint is like this. So we can write this as x plus 3y minus 10 equal to 0. Just these are, I mean, the format of everything is same only, so you can write like in this form. So you can write like L of x comma y comma lambda equal to it will be written in the form of 49 minus x square minus y square. Yes, I am getting the answer. We'll see that. Okay. Okay, yeah, we'll see that. 49 minus x square minus y square minus lambda into x plus 3y minus 10. Okay, so that is the L, and then what we can do is find the first order derivative. So it will be giving like L dash will be like minus 2x minus lambda. Next one will be minus 2y minus 3 lambda, and the next one minus of minus x minus 3y plus 10. Okay, so solving for this first one, you will get lambda equal to minus 2x. This one will be lambda equal to minus 3 lambda, sorry, y equal to or you can write this as x equal to minus lambda by 2. Okay, this one you'll get like lambda equal, directly I'll write like y is equal to minus 3 lambda by 2. Okay, and you can substitute in this particular equation. Just I'll mark it like 2 and 1, so, and this one has 3, so 1 and 2 in 3, if you give, you can substitute and get the answer of lambda as minus 2. Okay, then it will mean that x equal to minus 1 and y equal to 3. So what you can have is, you can put the value for f of x equal to minus 1 and y equal to 3. Alright, and you'll be getting the answer. You can check the answers once more for those who have got the option as A. So it will be like 49 minus 1 minus 9 will be coming, right? So answer will be 39, which is option D. So those who have put option A, just please check once and tell me. So I hope those who are given the option A is clear. Okay, the answer is option D. Okay, yeah. Next one, consider the optimization problem x square minus xy plus y square subject to the constraint. This one, just we have to find the Lagrangian function for the above optimization problem. Okay, so it's minimized. Just we have to, so this you have seen in the examples also. Just we want to see whether everything is in the same form in the minimization pattern, in the pattern of minimization. So this one anyway, it's like minimized. The next one is x plus 2y greater than or equal to, right? So you can write it like in the form 2 minus. Okay, so 2 minus x minus 2y less than or equal to 0. Here it will be 2x plus y minus 1 equal less than or equal to 0, and the next one will be minus 1 minus x less than or equal to 0. I am getting answers like D. Okay, so anyway, if you write the Lagrangian, you will be getting like Lagrangian of x, y, mu1, mu2, mu3. Okay, I am getting different answers now, A as well as D. So we'll see that. So x square minus xy plus y square will be the initial one. Okay, and then everywhere it's plus mu, so we'll put plus mu1 into, okay, so already we have done the minimization way, right? So it is like 2x plus y minus 1. Okay, so 2x plus y minus 1 is in these three options A, B, C, right? Then next thing we'll see mu 2. Mu 2 is written like 2 minus x minus 2y is okay, right? 2 minus x minus 2y. Okay, so here two of the options are coming, A and D, but anyway the other one is not there, but we'll write the third one also, plus mu 3 into minimization is like minus x minus 1. So the answer is A. If anyone has any doubt, just you can mention. So answer is A. So one of you had given answer D. So I think it's okay, right? So the answer is, so yeah, this I'll remove later. X square minus y square plus y square. Okay, I think it anyways. So this answer is like this one. Okay, now questions, yeah, questions from July 2023. So I think, yeah, so this is one set of questions, two sets of previous year sessions are over. Now this one is July 2023. So the values of mu1, mu2 and mu3 while evaluating the KKT condition with all constraints being inactive are, you can straight away give this answer. Yeah, this already have been solved. Now so the answer is P. Gradient based algorithm methods compute. These are all theory based questions. You can give the answer. I think one person has written, yeah, I think you have all given the answers. So answer will be both direction and step length at each iteration. The point on the plane x plus y minus 2z equal to 6 that is closest to the origin. So this is like we have solved two questions, two similar questions. One was a circle and the other one July 2023 exam. It's not available with me, Vaishali. Similar kind of questions will be coming only in the exam. It will be a little complex problems also, but it can be solved with the present theory which you have studied. You don't have to write program. I mean, you won't be having RStudio, but just you will be sometimes be asked how to include certain things, or you will be asked to check some programs or something. You won't be asked to write any program as such as you will write in an RStudio. Just some syntax you might have to know, and some libraries, and maybe some logic also on how to find the problem, because later you'll be getting some other, in the coming weeks there will be regression problems and all. So in that cases and all, you should be knowing how to do that in RStudio. Based on that, some questions might come. Okay, so I am getting different answers for this one, A and D. Okay, so for this particular problem, it's like this one is the initial question. Okay, sorry, closest to the origin is asked, so we'll be putting it like x minus 0 the whole square plus y minus 0 the whole square will be our f of xy. Okay, so it means like f of xy equal to x square plus y square, right? Yeah, subject to the constraint, this one you can say. So in that case you will be getting the values. So anyway, you should be writing it in the form of, so anyway, just I'll give you how to solve this ones, because it's like this one is two equations and this one, it's a plane, right? It's a plane which is given, which has three variables. So what you can do here is, so just one more thing will be, since it's a plane, it will be z minus 0, right? Oh, sorry, z minus 0 the whole square. So one who had given a is already 0 0 0, right? So closest to the origin, which is on the plane, will not be a. Okay, you can solve it once more and see. So anyway, we'll also be solving it here. So z square plus y square plus, sorry, x square plus y square plus z square will come here. Okay, because it's a plane. In the question it's given as a plane, and this is our condition. So what here we'll be doing, one way you can do is you can substitute for z square with help of the equation which is given. So here, from here you can give it like z equal to 6 x plus y minus 6 by 2 will be z, right? So what you can do here is like f of xy, you can write like x square plus y square plus x plus y minus 6 by 2 the whole square. In this way also you can solve this one. So you will be getting, so since we have made it to like in two variables, you can find dou f by dou y and dou f by dou x. Okay, so dou f by dou x you will be getting like in the form 2x plus 1 by 4 into, yeah, I'll write that, 2x plus 1 by 4 into x plus y plus y minus 6 into, sorry, 2 into 1. Okay, and this one will be coming like 2y plus 1 by 4 into 2 into x plus y minus 6 itself you will be getting. And finally the answer, when you substitute it to 0, okay, this one equal to 0, equating it to 0, and this one equating it to 0, you will be getting the following equations like 5x plus y minus 6 equal to 0 and x plus 5y minus 6 equal to 0. Solving these two, you will be getting x comma y equal to, not x comma y, sorry, x equal to y equal to 1 you will be getting. Okay, so then we will go here and substitute for z. So z will be coming like 1 plus 1 minus 6 by 2, that will be giving like minus 2. So answer will be D. I think everyone has now written the answer, so the answer is D. Next one, find the maximum value of f of xy. 49 minus x square minus y square subject to the constraint x plus 3y equal to 10. Okay, so here, yeah, here what you have, I think you have seen this question earlier itself, right? The answer was similar question you had seen earlier. You can tell me the answer. Yeah, same thing, same question we had seen earlier also. Okay, so you can refer the earlier slide. So answer will be 39. Okay, yeah, the minimum value of f of xy equal to x square, okay, x square plus 4y square minus 2x plus 8y subject to the constraint x plus 2y equal to 7 occurs at the below point. This also we have seen earlier only. Just I'll write the question once more. F of x equal to x square plus 4y square minus 2x plus 8y subject to the constraint x plus 2y equal to 7. Okay, so first what you have to do is write the Lagrangian. Anyone has the answers for this one, you can put that in the chat window. Okay, so this one is like direct. What you have to do is you have to write the Lagrangian. Okay, just x comma y comma lambda equal to x square plus 4y square minus 2x plus 8y minus lambda into x plus 2y minus 7 equal to, this is the Lagrangian, sorry. Then you can find L dash of xy lambda, and you will be getting around some values. Like, I'll just write this one down because we had already seen the similar one. So this will be the answer. And now if you solve for these things, you will be getting the value of x like 5, y as 1 and lambda as 8. Okay, so the answer will be D. This similar question already has come up. Okay, so questions are repeating in the different assignments. Then which of the following statement is or are not true with respect to multivariate optimization? You can see this one and tell me the answer. So I've got one C and D. Okay, like so the answer will be, okay, I have got many C. So it's like, okay, first we will see which is, so Hessian is a non-symmetric matrix. It is a false statement. Okay, this is a false statement. We are asked to find out the false statements. So now looking at these three, the gradient of a function at a point, is it parallel to a contour? Actually, no, it's not parallel, right? It's not parallel. Then gradient points in the direction of greatest increase to the function, that is true, and negative gradients point in the direction of greatest decrease of the function. So anyway, that two options are coming in C. For those who have answered D, I hope it's clear for you. Okay, gradient is like, it always goes, I mean, positive gradient will be like increase of the function, and negative gradient will be like direction of greatest decrease of the function. Okay, and this will be not a parallel, it will be like a tangent. Okay, I mean, it anyway won't be parallel. So those who have given D answer, I think they are fine. Okay. The solution to an unconstrained optimization problem is always the same as solution to the constraint one. Is it true or false? You can put the answer. I'm getting false. So this anyway, everyone is giving similar answers, so it's okay. Now the manufacturer incurs a monthly fixed cost of this much, and variable cost we have already written that, and revenue generated is also written. So how many units produced each month, I think we have already answered it in a previous slide, right? Okay, so if anyone has any doubt, we can go back to the previous slide and I'll explain. Otherwise the answer is B, m equal to 90. Okay, now for an unconstrained multivariate optimization given f of x, the necessary secondary condition for x star to be the minimizer of f of x. You can give the answer. So what will be the answer? It should, for the minimizer, it should be positive definite, right? Okay, then the function f of xy equal to 2x square minus 2y square, we are asked to find the stationary point. Just directly you can solve for this equation and solve for this function and tell me the answer. So I am getting answer as D. Sorry, B. Yeah. Okay. That's true. Okay. Yeah. The answer is B. So these are the set of questions which were available. Just I have given a framework. This already you might have seen in your lectures for solving data analysis problems, because we will be looking at many data analysis problems in the coming weeks. So first a problem statement will be given. This will be one precise statement of the problem. Then we will be conceptualizing the problem. That means that many different dependencies will be checked. Like earlier we have seen how to calculate the correlation between different variables, and we will be looking at whether it is a classification or a function approximation. So in real data analysis problem, it will be called like classification or regression problems, right? So in that way we have to see whether it is that kind of it's a classification, like seeing between one or two target variables, or whether we have to fit a particular line and find a particular value. Then we have to see if there are any other sub problems that need to be solved. So this is like problem conceptualization. Then after that, solution conceptualization will come, and this will include list assumptions, then flow charts and pictures based on the different data. Then we will do the method identification, which will include different tools, algorithms and mathematical constructs. So in this way you can tell it like this will include the models, different models. In ML case, it will be like different methods, different types of ML algorithms you will be telling, and you'll be also be checking like whether you want to reduce certain features or you want to combine certain features. So some kinds of feature selection as well as feature engineering will also be coming in that level. And then we will be looking at realization of the solution, and in the realization you will be looking at different performance matrices. So in the next weeks you will be seeing like for classification you will be looking at accuracy, precision, recall, all those things, or it will be like sensitivity, specificity. It's known as, in other terms, it's known as sensitivity and specificity. So we will be looking at that metrics, and if it's like a regression or a function approximation problem, then you will be looking at the error, like root mean square error, and these metrics are then looked, and if the assumptions are satisfied and solution is acceptable, then it will be the final solution. Otherwise, if it's not acceptable, then you will be again going to the assumption. The bottom of the slide, this much only is there. Okay, yeah, this much only will be the final thing. I mean, just I've given just like a picture because this will be the final picture. Okay, this slide you have seen in your lecture slides also. So this is for the coming weeks. Okay, so anyway, if you have any doubts for any of the questions that I have discussed earlier, you can just tell me. So I think everything's clear with everyone, right? So what I'll do is, like today's session, we can stop today's session, right? So I think the similar problems might be coming in your assignment also. So anyone has any doubt, you can ask. So just I have kept another slide also under RStudio so that you can go through the things which you can see for the coming weeks. Okay, just familiarize with the RStudio, because in the coming weeks we'll be using a lot of programs we'll be doing on RStudio also. So yeah, one person is asking a question. Colab, usually you will use Colab for Python if you want to do it in Python environment, right? And in your course also it's told to do it in RStudio. Yeah. Colab works works in Python environment, right? You can do the same problems in Python, that is true. Yeah, but right now the program asks you to do it in RStudio. Okay, you can do that. But anyway, it's so I think we'll stop the session for today. So I hope every question is clear with you. Right, okay then. Thank you everyone. Have a nice rest of the day.